For our next problem, we're given a rational function. We're first asked to find the domain of the rational function and then use several steps to graph it. So we have f of x is equal to 1 over x minus 1 plus 2. In this case, I'd like to write the rational function as one expression. So we'll rewrite this by simply taking the 2 and multiplying it by x minus 1 over x minus 1 to get the common denominator. And when we do that, we'll have the common denominator of x minus 1, and we'll have 1 plus 2 times the quantity x minus 1, which gives us 1 plus 2x minus 2 over x minus 1, and that just simplifies to 2x minus 1 in the numerator over x minus 1 in the denominator. Now that we've written it as one rational expression, we can say that the domain of this function consists of all real numbers except any value that would make the 0 in the denominator. So if we let x equal 1, we can see that the denominator would be 0. So therefore we can say that our domain is that x is not equal to 1. And I could write this in set notation or interval notation as well, but we'll leave it like that for now. Now, let's go on to several steps in order to help us graph this rational function. The first step is to determine if there is any symmetry. So, in order to determine symmetry, we look at f of negative x. I'm going to substitute negative x right into here. I'll put it in a box so we can refer to it. Into this function. If I substitute negative x in for each x, I'll end up with negative 2x minus 1 in the numerator, and I'll end up with negative x minus 1 in the denominator. We have three possibilities. If f of x is exactly the same as f of negative x, then that means we have an even function and it's symmetric with respect to the y-axis. That's not the case here. If f of x is exactly the opposite of f of negative x, we have an odd function and the function is symmetric with respect to the origin. If it's the opposite, that means every single term has to be the opposite. So we have a positive 2x in our original function and a negative 2x in f of negative x. However, they both have a minus 1 following them. So it's not the opposite either. So in this case, we have no symmetry and we'll write none. Let's move on to step 2. Step 2 is to find the y-intercept, if there is one. So in order to find the y-intercept, we just let x equal 0. So we're really finding f of 0. Again, I'm going to substitute it into this expression right here. We have 2 times 0 minus 1 over 0 minus 1. And this reduces to positive 1. So we know we have a y-intercept of 1. Next, we'll find the x-intercept or intercepts if there are some. We do that by letting y equal 0. In other words, we let f of x equal 0, and the easiest way to do it is just to set 0 equal to the numerator only of this rational expression. The only way this expression can equal 0 is if the numerator is equal to 0. So 0 equals 2x minus 1 does have a solution. If we solve for x, we get x equals 1/2. So x equals 1/2 is our x-intercept. Next, we want to look at asymptotes. Let's first, in step 4, look to see if we have any vertical asymptotes. We find vertical asymptotes by setting the denominator equal to 0. Well, if we set x minus 1 equal to 0, we get x equals 1. So that is our vertical asymptote. Next, I'll come up here for step 5. We'll look to see if we have any horizontal asymptotes. We look at our expression and we compare the degree of the numerator with the degree of the denominator. In this case, our degrees are the same. They both have degree 1 since x is to the first power. So our horizontal asymptote is going to be of the form y equals, we just look at the ratio of the leading coefficients. The numerator coefficient is 2 and the denominator coefficient is 1. So therefore y equals 2 is our horizontal asymptote. Now finally we move on to step 6 where we plot a few points. But before I actually do number 6, I'm going to sketch in some of the information that we already have. We know that we have a y-intercept of 1. I'll put that right here on the y-axis. And we have an x-intercept of 1/2 right here. We also have a vertical asymptote at x equals 1. That goes right through the x-axis. And a horizontal asymptote of y equals 2. The reason I sketch this information first is because it helps me pick my points in number 6. In number 6, I want to pick any points that are either in between an x-intercept or a vertical asymptote. So I have an x-intercept here at 1/2. Let's choose a point to the left of 1/2. Let's let x equal -1. If I substitute -1 into my rational function, I'll get a value of positive 3/2 for f of x. It's just a matter of substituting in -1 and simplifying. So -1 3/2 is a point on my graph. Now let's choose a point between 1/2 and 1. Let's pick, say, 3/4 for x. If I substitute in 3/4 into my rational function, then I'll get the value -2 for f of x. So I'm going to plot that, 3/4, comma, -2. And then finally, let's choose a value to the right of my vertical asymptote. I chose the value 2. When I substitute in 2 in my rational function, I end up with 3 as the function value. So 2, 3 is my function value. Now I'm ready to make my final sketch, remembering that when I make this smooth curve, it always tends toward the asymptotes. And there's a graph of my rational function.